everything working for us. So I want to talk about just a few course items first. I have been putting videos in Canvas from this course when I record. So I do need to download and upload them, and I had some tests that I needed to grade. So I need to upload the one still from Tuesday, but I will do that right after this class. I want to make sure you all have every resource available that I can make. So because everybody learns differently, we have different learning styles, and I don't know why that won't let me in. Okay, but I think I'm good. I just want some way to get to Canvas, so I think I found a way right here. So let me go ahead and get into Canvas. And I want to get into our particular course, which is 12009. So I want to do this today because, first of all, you see the announcements here. So I should go into student view so you can get a better, so you can see what you're going to see. So to view all announcements, you want to make sure you are clicking on announcements over here towards the left, and then you can look at all the announcements. So it's every student's responsibility to know the content of all Canvas announcements. So even if you haven't read them, I'm going to assume that you have, and you know the content of all of those. So it's very important that you know how to get a clear picture of your government issued photo ID in order to avoid a testing violation. And so you want to make sure you know the content of all of these, and it's really great and good. And I would encourage all of you to review these announcements before you take each test in this course, so that will minimize your chances of getting a testing violation. So I don't want to give out testing violations, but I'm required by our department to do so. So, that's not my choice. That was a departmental decision. So I really can't avoid doing that. I wouldn't be, what do I want to say? I would violate my commitment to the college if I did that. So I can't do that. As much as I want to, as much as I like you all and want to see you all succeed, I can't really do that. That was an institution decision to have proctored testing, and then with that comes the violations and so forth. So let's look at modules because I want to make sure I show you. Here are the video links to the videos that we have recorded. And I still will add that one from Tuesday down here. I'll do that right after class. So you've got that to watch, and you don't have to watch all parts of it. You can just watch the parts that you need. So that could help you, get a good score on the objective that's due tonight. I will also upload my notes from Tuesday's objective to Alex. And where will those go in Alex? Let's take a look. Yeah, so let me show you. Let's go back up here. You all enter on the home screen. To get to the main menu, click on these 3 horizontal bars. I will be putting my notes in instructor resources. And then you will just want to click on objective notes and you will see the notes. I'll add them at the bottom. I haven't been adding them recently because my workload has increased a lot. It's that time of the semester. So if you really want to use them, I will be glad to do so. I just haven't heard any students talking about using my notes, or gotten any comments about that. But if they're beneficial to you, I will be glad to do it. So they're under instructor resources. While we're here, I want to mention when the test 3 is. Test 3 is coming up pretty quickly here. We have a little over a month left in the semester. So we don't have much time left. And in that time, you will be taking test 3 and also the comprehensive final. So there's a lot going on here in all of your courses, I'm sure, since the end of the semester is close. It's just a few weeks away, really, maybe 4 or 5 weeks away. I don't remember exactly when the finals are, but they're pretty early in December, actually. So I want to look at our calendar here. I like the 2-week view. And you can see, I think I need to extend the due date of this test 3 review no credit assignment. But there is a test coming up. And so I'm going to click on the forward pointing arrow here. And you can see test 3 right here. It's on November 24th. If you want confirmation that it's on November 24th, you can click on the icon and it says due 12 p.m. Now I will extend the time because I'm not looking at your ALEKS course. I'm actually doing the one that was before yours. Your time will be different on that day, but it will still be on the same day, November 24th. That is 2 days before Thanksgiving. It's on Tuesday, November 24th. So I just want to let you all know that that is when test 3 is, and you're welcome to look at the calendar at any time you want so you can see ahead. To get a sense for when finals is, let's take a look. Here's the final. This is a way, so this is the actual date of the final. You will see it written twice, the word final. That's because in order to drop the lowest test score from your first 3 test scores, I have to I have to manipulate the ALEKS system to do it correctly. Otherwise, it's not going to, the weights won't be correct. And so I had to manually creating manually another category for final exam and putting the finals in by the scores by hand myself, because otherwise the weights aren't correct. According to departmental policy, I have to make the final worth at least 20% of your grade. So your final is worth 1/5 of your course grade. So this is the date of the final right here. It's like it's going to be on December 15th. So just to give you an idea of the time frame of the rest of this course. Anybody have any questions at this point? I just wanted to kind of put it in context for you. It's a good idea to have or make a plan for how you're going to prepare for the final. So to help you prepare for the final, you will see that I've got a final exam review part 2 for 5% bonus assignment. So the finals were 20% of your grade. This one bonus assignment is worth 5% of your grade. So you could look at it as, 5% is like 25 points on the final. So it could definitely be the difference between you passing the course and not passing the course. Anyone who passes the final will automatically pass the course in this class. Anyone who passes the final, I will say it again, anyone who passes the final, the comprehensive final in this course, will pass the course. I cannot drop your comprehensive final. That is against departmental and division rules. So I cannot drop the comprehensive final. It has to count, and it has to count at least 20% of your grade, according to departmental policy. And I know instructors at NWAC that counted for more than 20%. I'm at the very bottom of what I can count it for. So I really do have your best interest at heart to tell. So, and then there is also another review part 1 assignment that is worth credit, that, and it's worth, they're both worth credit really, but the part 1 is worth course credit. It's not bonus points, it's worth course credit. And from those 2 final exam review assignments, those are what you really want to do and do over and over again, writing out your written work as you go, because all the problems on the comprehensive final are going to come from one of those two assignments. They're either going to come from the bonus assignment, or they're going to come from the part 1, which is worth 5% as well. And so, though, that's really a great way to prepare for the final. You do want to think about what written work you're going to show, though. So that's could be part of your plan. And you want to make sure going forward that when you do your time management, that you want to block out some time to be able to work on those assignments. Anyone have any questions at this point? Just go back up to Teams here. Olivia, do you have a question? I'm just going to take one more.
I just wanted to say that I do use the notes a lot.
Okay.
To help me, so.
Okay. Okay, so I'll put the notes. I'll put the notes in, Alex. You like the notes?
Yes, I do.
Okay, that's great. That's good. Anything I can do to help y'all. Don't forget, we have those recordings too, and that records the notes at the same time. You just may prefer just to having the notes there. And I do write out the written work topics too. So I've been putting those notes there. So there's lots of resources. And I do that because I want to make sure I'm reaching all of my students just with the different learning styles. And I need to know what you need, because I wish I had a crystal ball and knew all of your learning styles, but I don't. That would be so nice. So any other comments? Thank you, Olivia, for that comment. Okay, let's begin to our objective for today, which is looking at quadratic functions. And I will also, at the same time as I put the notes from the objective that are due tonight, I will make sure I put the notes in from today. So let's get started. We're going to go down to my desktop here. And let me make sure I get down there. And I want to click on this. And that was from last time, but let's take a look at this. We're going to look at quadratic functions and their applications. We're going to be finding 5 ordered pairs to help us graph a quadratic function, and then we're going to graph that quadratic function in the ALEKS software, which is why I encourage all of you to have your graphing calculators. So if you don't have them nearby, if you can get them real quickly, I would encourage you to grab them so that we can take some time to work with the graphing calculator. I worked with it with my last class and it went pretty well. So we are looking at the objective quadratic functions and applications. The simplest quadratic function of all is f of x equals x squared. That is a parabola sitting on the origin that opens up. We must have the x squared term in our equation or in our function. I mean, equation is just has an equal sign, which this does. So we must have that x squared term. So the formal definition of a quadratic function is f of x equals ax squared plus bx plus c. This a is a number. This b is a number. This c is a number. This a is called a coefficient. A coefficient is a number multiplier. So this a is a times x squared. It's specifically called the leading coefficient because our quadratic function is written in descending power order. So our first term here has has an exponent of 2. Our second term has on the x an understood exponent of 1. So the exponents are going down. 2, 1. This is times x to the 0 power. So that would be 2, 1, 0. So a quadratic function is f of x equals ax squared plus bx plus c, and the a can't be 0. So this leading coefficient here cannot be 0. If it were 0, it would be 0 times x squared, which is 0. This term would get wiped out, and then we would no longer have a quadratic function. We would actually have a linear function at that point. So we must have this term here, this x squared term, and the simplest one of all is y equals x squared. There's actually an understood leading coefficient of 1 here. So it turns out that the graph of such function of each of these quadratic functions is a parabola. It's a U-shaped graph that passes the vertical line test, and this U-shaped graph opens down. It spills water. Well, this one, however, opens up. It retains water. It keeps the water or the soup or whatever you want to think about. So the graph of these functions, of each of these functions, the graph of f is a parabola with this vertex. With vertex what? So the vertex is here inside these parentheses. The x coordinate is negative b over 2a. The y coordinate this is just telling us to find the y for this particular x. That's all it's telling us. Find the corresponding y. You don't have to be concerned about this notation. This, yes. And what's nice about this is actually x equals negative b over 2a. Just to make that clear, let me do this. This is actually x equals negative b over 2a. Can anybody tell me where else in the course we've seen x equals negative b over 2a? We've seen it in a formula in the course before. It's part of another formula. And that formula is, dun, da, da, the quadratic formula. So the quadratic formula is x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. You can write it with a single denominator of 2a. The entire quadratic formula that is, but I didn't have room to do that, so I wrote it like this instead. I put the 2a down here. So the x coordinate of that turning point of that vertex, you can find by using this, x equals negative b over 2a. And if you know the quadratic formula, you know the first part of it, which is x equals negative b over 2a. So that's how we find the x coordinate of this turning point right here, this vertex right here, or this vertex right here. And then to find the y coordinate, you just take and whatever relates x to y in the problem, you plug in the whatever number you get for the x's and you solve for y. Now we have two possibilities here. We have a parabola that opens down, and we have a parabola that opens up. Going on here, if we come in from negative infinity, the y values are going up, up, up. Here they're increasing. The y values are increasing. They're getting larger, they're getting bigger as we go up on the y-axis. Then we reach a turning point with these types of graphs. That turning point in this sketch here is a high point. It's a maximum. It's the highest point of the entire blue graph. And then, so we switch from increasing, going up, up, up to our y values then going down, 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 down. In other words, the y values are decreasing on this side. They're getting smaller. We'll talk about the red dashed line in a minute. So over on this graph, we've got this graph. So what happens if we come in from negative infinity? The y values are going down, down, down first. And at this turning point at the bottom here, to then the y values go up, up, up. They get bigger and bigger and bigger and bigger. So over here, the y values get smaller and smaller and smaller. Reach the turning point, turn around and go back up. So the y values then get bigger and bigger and bigger. So how do we tell whether we have a graph that looks like this, in other words, opens down, or a graph which opens up? Well, that miraculously is controlled by this leading coefficient, this a here. If that a is positive, like over here, we have an understood 1 in front. That leading coefficient is 1, which is positive. If I'm positive, I'm having a really good day, I'm up. I'm not down, I'm up. Positive goes with up. Makes me think of the movie Up. So positive goes with up. That's how I remember. That means when you have a positive leading coefficient, in this case we do, the parabola opens up, which means it opens like this. So in this case, we have a low point, we have a minimum point down here. So right here, we have a minimum point, what we call a minimum. So that's the minimum. So if A is positive, the parabola opens up and the vertex is a minimum point. If, on the other hand, if that leading coefficient, that A, is negative, the parabola, we have this situation. And in that case, that turning point, that's the highest point on the graph. So its y value is the largest y value on that entire graph. So we then have a maximum point. That y coordinate of that vertex is the maximum y value. So we have a maximum point if A is negative. So we are in this case here. In other words, our parabola opens down. So if a parabola opens down, in other words, if I'm feeling down on in a particular moment, like I watched something on television I wasn't happy with, then because I'm feeling down, I then fill negative. So down goes with negative. Up goes with positive. Up goes with positive. Any questions? And I can't really, I can maybe squeeze in a little bit the word maximum here, at least an abbreviation for it. Not a lot of room to work here though. So this is the maximum point right there. Any questions so far? We already looked at finding, we looked at x equals negative BA equals negative B over 2A. That gives us the x coordinate of the vertex. These two parabolas here, there's symmetry going on. Let's look at this parabola, the one that opens up. And I'm a little hesitant to mark it up, but I think I'm going to go ahead and do that. Let's pick how the green works. I'm not sure how the green's going to work, but let's try that. If I look at this side, oops, see, that did not work. That is not what I want it to have happen. Just let me close this down and start, see if I'll try it one more time. I don't want to, I want my notes to stay nice, so I don't want to risk that. And let's see if I can get the green back and try one more time. I've got to click on this, yeah. Okay, so I'll go here. So I want to look at this side and see if this will work. Just trace over that the best I can. So I'm looking at this. So let's just look at this. Now what I did is I drew a vertical dashed line right through the center of this parabola, right through the vertex of it, the turning point. That is not actually part of the graph. It's just an axis of symmetry. It's not part of the graph. None of those, this line here, which is actually a dashed line, no ordered pairs intersect our graph except for the one at the vertex. But it's not part, so in a sense it intersects the graph, but it's really not part of the graph. But there's nice symmetry property. We have really a nice symmetry property going on. So if I took this piece of the parabola and I flipped it over the axis of symmetry, it would lie exactly on this part of the parabola. And we are going to use we see that symmetry in a t-table that we are going to create today that we're going to use to do a graphing problem in ALEKS. So not only can you use x equals negative b over 2a to find the x coordinate of the vertex, you can also use x equals negative b over 2a to find the equation of this axis of symmetry. And that's the first part of the quadratic formula, x equals negative b over 2a. So you've got the first part of the quadratic formula. So negative b over 2a is the first part of the quadratic formula. It is the x coordinate of the vertex, and it is the equation for the axis of symmetry. So the axis of symmetry is x equals negative b over 2a encircled here. This is the vertical line, actually vertical dashed line that passes through the vertex. And I was just doing the bottom of the quadratic formula here. So any questions on this first page? There's really a lot there. And one of ALEKS's perhaps drawbacks is it doesn't do an overview. and I like to do an overview. Try to put everything into context. So let's look at this particular document first, this topic, and let me just talk you through what we're going to do in ALEKS, and then we'll go get a different problem and do it in ALEKS. So we want to graph the parabola. So those U-shaped graphs we've been talking about, they're called parabolas. We want graph the parabola y equals negative x squared plus 6x minus 11. In order to graph a parabola, we really need to find the vertex first, and we have a formula for the vertex. So that formula is got to click on here to turn on this color over here. And let's look at this one. I think I can click that off later. And so you just go grab this. Oh, it turns to a dot. That's really cool. So if you want to find the vertex, it's just negative b over 2a for the x coordinate. And then for the y coordinate, whatever the corresponding y coordinate is. Don't need to have any fancy notation there. So we need our a and our b. So we go to our given quadratic equation. Must be quadratic, must be in the form ax squared plus bx plus c. We do not have to have the x term or the constant term, but we must have the x squared term. So this is written in descending power order, to an exponent of 2 up here, an exponent of 1 there, an understood 1, and then a constant term. It's in descending power order. So our a is that negative in front. A negative is really negative 1. You can replace that negative sign with a negative 1. So our a is that coefficient, which is negative 1. Our b is the coefficient of the middle term, which is, or the coefficient, and you could say the coefficient of the x term, which is 6. So our b is 6. So a is negative 1, b is 6. Let's find the vertex. To find the vertex, it's x equals negative b over 2a. Copied that down, equals negative. Our b is 6. So I put 6 there. Over 2 times a is negative 1. Negative, remember division's really multiplication by the reciprocal, so division's really multiplying. So a negative times a negative, if you will, is a positive. So we get positive. Then we have 6 in the numerator, and in the denominator we took care of the negative, so we can ignore it. 2 times 1, which is 2. So 6 divided by 2 is 3. So our x is 3. To find the y coordinate of our vertex, we need to go back to the original function. That's what relates x and y. So our original function is up here, and they could have written f of x, but they wrote in y. So we want to plug in the x that we got, which is 3. We want to plug that 3 in here and here. So we get 3 squared. Now when we plug in this 3 here, so we want to plug in this 3. For x, right there. We want to make sure we're going by PIMDAS, parentheses first, E for exponent. So we've got an exponent here, so we want to plug it in the 3, put parentheses around it, and square it. And then we have the negative sign out front. So that's going to be negative parenthesis 3 parenthesis squared, like this. Plus 6 times 3. We're putting 3 in for x. So that will give us 6 times 3 right there. And then minus 11 right there. So what do we have? We have a negative. Just copied it down. This exponent. Exponents are mathematicians' way of actually the mathematician's shorthand for repeated multiplication. This tells us we want 2 of these 3's multiplied together. So we really want 3 times 3, which is 9. Plus 6 times 3, which is 18, minus this 11. So let's figure out, let's do this calculation. So I'm looking at this and I've noticed that we've got negative 9 minus 11, which is negative 20, plus 18, which is negative 2. So our y coordinate is negative 2. Our x coordinate is 3. Our y coordinate is negative 2. So those are the x and y coordinates of our vertex, and I put the vertex in the middle. That's an ordered pair, and it's in the middle of the t-table. And you will notice that if I go take negative 2 and let's see here on this side, I take this 3, subtract 1, get 2, subtract 1 and get 1. And then I go in this direction, and this time I add. 3 plus 1 is 4. 4 plus 1 is 5. What's going on here in the y, with the y's? Here's our vertex. This is negative 2 is the y coordinate of the vertex. If we go back, we get negative 3, negative 6. But if we go forward, we also get negative 3, negative 6. That's because of the nice symmetry that goes on with parabolas. So we're going to use this strategy of this t-table here, the way it's constructed, to get a t-table to graph in ALEKS. So let's play around with the graphing calculator while we have a problem that we know the answers to see if we can get the answers. Feel free to ask questions. I had a student last class earlier today. She was asking questions and confirmed for me, you know, some of my answers, and it was quite fun. So please bring to your remote classes exactly what you would take to a live class if you were going to campus, so that you can get the most out of the class. I encourage everybody to get as much out of your class time as possible, and that includes asking me instructors asking me questions, because we don't meet often. We only meet twice a week, which you could say is maybe too little. So anyway, let's see how I was able to construct this t-table. So I started with knowing that my vertex, the ordered pair for the vertex, was 3 and then comma negative 2. So I put that in the t-table. I then took the 3, subtracted 1, took the 2, subtracted 1 to get my axis. Then I took the 3 and added 1. 3 plus 1 is 4. Took the 4, added 1. 4 plus 1 is 5. And to be clear, I did it this direction too. Took the 3 and subtracted 1. 3 minus 1 is 2 minus 1 is 1. That's how I got the x's. ALEKS wants you to graph 5 ordered pairs here. And that's how they want to get those ordered pairs. If you do it any other way, you might be out of range of the graph. And that would cause a problem. So the very first thing that I want to do is I want to take a look at this static graphing calculator, and we want to go to y equals, this button right here, and put our function in for y1. So we want to do y equals and put our function in for y1. So you want to enter your function in y. You want to go to y equals. And click on the y equals button and put your function there. So I'm going to go to y equals, push that button in the upper left, y equals. And an easy way to clear your, I'm in y equals now. And an easy way to clear your screen here is to use the clear button right here. You want to clear something off? You can use that. So I'm able to, my cursor is flashing in Y1 right now. I'm going to do a clear and everything went away. So I don't have to have that confusing function, that old function, and have to deal with it at the same time as I'm putting in the new one. So I'm going to enter the new function right now. And that new function is, let's go back up to the top where we can at that function right here. Y equals, so Y1 already takes care of that Y equals. So after that, we have a negative sign. The negative sign's in the bottom row here, very bottom right of the calculator. So negative X is right here. It's right next to the alpha key in the first column. If you go one button to the right, you can get to the button that will give you X. So X, mountain peak. So that mountain peak is over on this side, right above the division symbol. So mountain peak. That'll open up a box so I can put in it whatever I want. I'm going to type in a 2. And then you want a right arrow out of the exponent. The arrow keys are right here on the right side of the calculator. We want a right arrow to get ourselves out of that exponent. And if in any time you have a question or you missed a step or you're unsure, please ask, because I want you all to understand how to do this. TI-84 graphing calculators are in wide use across the country at all, at probably nearly every college or university in this country. ALEKS, the issue with the ALEKS graphing ALEKS calculator is they don't, first of all, have it for all problems. And number 2, you can't use it for your business class or any of your other classes that involve math, because it's dependent on having the ALEKS software. So it's really important to learn how to use the graphing calculator, especially if you are going to take any business classes, statistics classes, math classes. And that's why I want to make sure I'm spending some time on showing you how to use it appropriately, to use it correctly. So I have negative x squared typed in. I'm on the normal line of writing. I just want to hit the plus sign, 6, and then the x, and then the minus sign, 11. Double check negative x squared plus 6x minus 11. So I have that in y1. So now what we want to do is go to the home screen. So we're in Y1, we want to get back out on the home screen. And the way you get to the home screen is you do a second right here. You really want to quit, but it's above a button. So we have to use that second key first, and then so that we click on second, and then the button below the quit, which is mode. So to get to the home screen, you want to do a second mode. So let's do that second mode to get back to the home screen. Anybody have any questions so far about any of the steps that I've talked about on using the graphing calculator? We're going to do a lot more graphing towards the end of the course. We're not only going to graph parabolas, we're going to graph rational functions, we're going to graph polynomial functions. So it's very important that you know how to use the graphing calculator. So let's go on. So now I'm on the home screen. And what we want to do is we want to just we're not going to graph this one in ALEKS, but we want to play around with this enough so we can figure out how to get these y coordinates. So we're going to do a few of them. So we're on this home screen, second mode. And what we want to do now, and at this moment, our function is typed into Y1. So we want to go grab that function when needed on the home screen. And the way we do that is by using vars. It's short for variables. So vars. Vars is right here, right below the arrows. Right there. So let's click on vars. So I'm going to click on vars. Now, the next thing we need to do is right arrow over. So the right arrow's right here. Right arrow over to Y vars. And you will see at this step that Y vars has black over it. And the 1 has black over it. Any questions on getting to this step? So after we've gone over to Y vars, then all we need to do is type on the number 1 twice. So that is that's the number 1 down here. So I'm going to click on 1 twice, and I'm on the home screen and see Y1. So if you're not seeing Y sub 1 on the home screen, please let me know what I can do to help you. So then the next thing we want to do is enter a number. We want to put an opening parenthesis. So the parentheses are right down here above the number keys. Let's use an open parenthesis, and let's just put in 5. And let's see if we all get the same answer. So Y, in other words, I see on my screen Y sub 1 of 5. And I'm going to hit enter. Who wants to volunteer their answer? What did you get for an answer when, in other words, what's the Y coordinate of when X is 5? Anybody want to tell me what they got for an answer?
I think I did something wrong because I got error.
Okay, so what do you see on your screen before do you see, this is what I see on my screen. On my home screen. So I'll show you what I see. I see this on my home screen, and this is all I see on my home screen. Y sub 1 of 5. And then all the way over here, I see -6. So do you have your function entered into Y1? Did you enter your function?
That's exactly what I have on here.
On your screen right now?
Yeah.
Did you get to the home screen? So the home screen, I don't have mine turned on. You shouldn't, are you still in Y equals? Like, do you see the, let me do it this way. Do you see Y1 equals -x² plus 6x minus 11? Is that what you see? See, I'm trying to determine if you're in Y equals or if you're on the home screen. So do you see this part? If I go to do you see this part? I think I wrote it down here. Do you see this part at all? Anything of this?
I have the Y1 5 down.
Okay, so then why don't you go in, but when you hit enter, you got an error, is that correct?
Yeah.
Okay, so why don't you go into Y1 and let's make sure our Y1s agree. So I'll put my Y1 here. Equals -x squared plus 6x minus 11. That's what I have. This. Do you see anything that may be different in your Y1? So did you use the negative in the bottom row of the calculator? So sometimes students will put in minus sign in here instead of a negative. So,
yeah, I messed that up. I didn't even have a negative there.
So do you have it all correct now?
Yeah, I just fixed it.
Cool. Because this is a learning experience for all of us. Maybe it'll remind us all to make sure to use a negative sign there if the problem calls for. Okay, so you can go back to your home screen, and that's just a second mode, or you can look at it just as a quit. So we're all back on the home screen now. And why don't you try it again? Doing vars, y vars 1, 1. And then putting in that 5.
I got what you got.
That's great. I'm very proud of you. Really, I'm so proud of you doing that. I'm so happy. Anybody have any questions? Excellent. Okay, so we need to still verify some of these. I just want to play around. Let's do a couple more of these. Let's do one. Let's say we did 5 and we got -6. So let's do one more at the top here. How about we do 2? Now what you can do is rather than going and doing vars, y vars 1, 1 each time, you can do something simpler, which is what I consider the calculator's version of copy and paste. So you can actually, on your home screen now, you can go and click on the second button. And let me show you where we're going with this. So what we're doing is there's this enter button down in the lower right here, but above that is the word entry. ENTRY, that really means to repeat the entry on the home screen. So we really want to repeat the entry by doing, since it's above a button in blue, we have to use the second key, at least mine is in blue. I have to use the second key and then this button. So that's why I have a second enter right here. So if you try a second enter, look what happens. Second enter. It puts on my screen another y sub 1 of 5. Well, I can then use the left arrow key to go right, had to have that blinking cursor right over the 5, and we can change that to whatever else we want. So let's do that. Let's change it to, what did we say we were going to change it to, 1 or 2? What's the X going to be? I think I said 2. Let's just change that 5 to a 2 and hit it and hit enter. And I get -3, which is what is in the t-table here. Did you get -3? Did anybody get -3?
I got it.
Great, thank you so much. Thank you so much. So now what we want to do is we want to work one of these problems in ALEKS. And you can see I did one in my last class, so I need to get another. Let me see if I can get another document here. So let's do this, and let's go into ALEKS to get a question. So I'm going to go select. There we go, graphing a parabola. Start, let's get one that has a minus sign in it. Actually a negative sign, so let this one, this particular topic has another explanation, that's nice. More practice. So let's do this one. So I'm going to copy down our function, y equals -x squared plus 8x minus 20. Give you a moment to copy down that functions. And what we want to do is read this, plot 5 points on the parabola, the vertex, 2 points to the left of the vertex, and 2 points to the right of the vertex. Then click on the graph a function button. So let's go down here, and I'm going to make a t-table. Oops, gotta make sure I've gotta click on the draw tool. Not sure if that's going to go off, but I guess we'll take our chances here. I'll try to get it off in a moment, or we'll just incorporate it into what we need to do or something like that. Yeah, I guess we're stuck with it, but it's okay. We'll just do this. We'll make it look like it's part of the problem. Okay, so what we have here, X column, Y column. So this is a Y t-table. I guess it's going to highlight everything in blue for me. I didn't mean for that, but that we'll work with that. Our Y is negative x squared plus 8x minus 20. Let's see if I can. I don't know if that'll help, but we'll see. Anyway, so that's our function y equals negative x squared plus 8x minus 20. We need to find the x coordinate of the vertex. So that would be x equals negative b over 2a. So let's see if we can squeeze that in up here. So x equals negative b over 2a. And I need my a here. Okay, negative b over 2a. So what is that equal to for us? It's negative b is this 8 right here. So it's negative 8 over 2 times a, which is negative, this negative sign, which is really a negative 1. So that is our b. And let's clean that b up. We have a negative over negative, which is a positive. 8 divided by 2, which is 4. So 4 is the x coordinate of our vertex. Now, for some of these problems, you will get like negative 5 for the x coordinate, in which case you would want to back up and choose negative 6 and negative 7. And you'd also want to go forward from negative 5 and choose negative 4 and negative 3 for your x's. So let's go backwards and subtract 1 here. 4 minus 1 is 3, so we want to use 3. 3 minus 1 is 2, so we want to use 2. We want to go forward from our vertex. 4 plus 1 is 5. 5 plus 1 is 6. And whatever this is right here, this is going to be our x and y coordinates of our vertex. So let's find the y coordinate of our vertex. To find the y coordinate of the vertex, it's y, this is our y equals negative x squared. We go down here. So y equals negative x. Our x is 4. And I want to make sure everybody understands that it's a good idea to put that number in parentheses so you don't forget to square when you need the negative when you need to. So that's negative 4 squared plus 8 times x plus 8 times x. So that's plus 8 times 4. So that's 8 times 4 minus 20. So let's do that. And we could have put that in our calculator already, but let's just do this calculation. So this is down here, negative 4 squared. 4 squared is 16. plus 8 times 4 minus 20. And I get -4. Anybody else get -4? So the y coordinate of the vertex is -4. Any questions on how I got the vertex, the ordered pair for the vertex? And on how we took this -1, this -1, took this +1, +1. Now we want to go to our graphing calculator. We want to put our function in y1, this function right here across the top. So I'm going to go to y equals. I'm going to use the clear key. The clear key is right by it's in the rightmost column, right under the arrow keys. So I'm going to use clear. And so I can type in something new. So negative in the bottom row of the calculator, negative x mountain peak 2, right arrow out of the exponent, plus 8x minus 20. And then I'm going to go to my home screen, which is second mode. And the first thing I'm going to do, I am going to, remember what we want to do here. We want to do vars, y vars, 1, 1. So vars, y vars, 1, 1, parenthesis. And then what I'm going to do is I'm going to put in 4, because I want to verify this is truly the coordinates of the vertex. I'm putting 4 for my x. And I get out -4. So we can fill in this entire t-table in the same way. We can repeat the entry. So repeating the entry, it's just to repeat the entry we have on the home screen. It's just second enter. Second key followed by the enter key. So I'm going to do second enter. I'm going to use the left arrow to go over that 4 and change it to a 3. Let's back up. And I get -5. And then I'm going to repeat the entry again. And this time I've got a 3. I'm going to change it to a 2. And I get -8. Now I want to go in this direction. I'm going to repeat the entry again and change that 2 that's there to a 5. And I get -5. And one more time, I'm going to change the 5 to a 6 and get -8. And there's that nice symmetry. Here is the ordered pair for the vertex. If we go this way, we get -1 this way, we get -5, -8. If we go this way, we get -5, -8. That's that nice symmetry happening. So let's copy these down and enter these in ALEKS. 2, -8. 3, -5. 4, -4. 5, -5. 6, -8. Okay, let's go to Alex. And I'm going to select this graphing tool. What's nice about this is since we know what these graphs look like, and in this case we have a negative leading coefficient, so our parabola is going to open down, and we have an idea of what it's going to look like. So if something goes awry, we might be able to spot it pretty quickly. So the first ordered pair I'm going to enter here is 2, -8. Plot. It's already plotted it for me. Check. 3, -5. Check. Here's our vertex. 4, -4. Plot. 5, -5. Plot. And lastly, 6, -8. And that looks good. So I'm going to close out of here. I better plot that because I don't think I've officially confirmed that. Let's X out of here. And now we're just going to click on this graphing tool. Looks like a parabola to me. And so let's check. Any questions on graphing a parabola in Alex? So let's go back and take a look at where we were at in this document. Let's go and look at this topic now. So this topic is slightly different than what we did before, but the process of graphing is exactly the same. Graph the parabola. Y equals -3 times x plus 6 squared plus 4. So I just copied that function right down here. So the only thing that's really different here is this is given to us in what we call HK form. We're not going to really go into this. We've got HK form here. We're just going to work with it in a way that's easy to work with and takes advantage of what we have done last time. You were in the previous topic. So what's different here is we've got this factor here that's x plus 6 squared. Well, we know how to handle that. Exponents tell us, this exponent of 2 tells us we want 2 of this x plus 6 multiplied together. So that would give us -3. Here's here's an x plus 6. We want 2 of those multiplied together, so we have to write x plus 6 again, and then plus this 4. We have 2 factors here multiplied together. We have 2 terms in this factor, 2 terms in this factor, so that's when we can use FOIL. So let's copy this -3 here. The first 2, x times x, is x squared. The outer 2, that would be x times 6, which is 6x, plus the inner 2, which is 6x. So 6x plus 6x, 6 plus 6 is 12x. Last 2, 6, 36. And all of that in parentheses, plus this 4 on the outside. Right here, we have multiplication over addition. Remember, subtraction is just adding a negative. So you can have multiplication over subtraction to distribute. So we have multiplication over addition, so we're going to distribute this -3 through to get -3x squared. -3 times 12 is -36x. -3 times +36 is -108, plus this 4 on the outside. So just copy this down, copy this down. 108 plus 4 is -104. So that's our y. We could have been given this y in the very last problem, and we will work it exactly the same way. So in this form, we're just doing exactly what we did in the previous topic. We want to first find our vertex. So our vertex, the x coordinate is -b/2a. So we can't really, if you know what your vertex is in this form, you don't have to go through this. I mean, I can tell you what the vertex is here. You just change the sign on this number inside, get -6. The y coordinate of the vertex is this number right here, which is 4. It's a HK form. If you've learned that before, feel free to use it. So, but in this form, which is, I'm just going to focus on presenting this form, x equals -b/2a. So our x in this case is equal to negative from here, b. B is the coefficient of the x term, which is -36. -36. Divided by 2 times a. A is the coefficient of the x squared term, which is -3. Now we have negative times negative, which is a positive, divided by a negative is a negative. So we have negative 36 up here, 2 times 3, which is 6 down there. So 36 by 6 is 6. So we get a -6 for x. So we got a -6 here for x, for our vertex. Now to find the y, we just need to take and plug in -6 for x. And we can choose whatever y we want as long as it's algebraically equivalent. Let's use this. So we want y equals -3 x plus 6 times, let's see what we did here. We use this form up here. So what we're doing is actually plugging in -6 for this x. So we're plugging in -6 for this x up here. That's what we're doing. If we plug in -6 there inside the parentheses, we get -6 plus 6, which is 0 squared. 0, that is 0 times 0 is 0. And 0 times -3 is still 0. So we really get this whole term here is 0. Plus 4 is 4. So y equals 4. You can see it there. You can also see it here when I wrote it out. So the vertex is -6, 4, which we have right here. This is our vertex. These are the ordered pair associated with our vertex here. So if we want to graph an Alex, we go 1 back. So we take, in other words, we take -6 and subtract 1 to get -7. We take -7 and subtract 1 to get -8. Going in this direction, we take -6 and add 1 to get -5. Take -5 and add 1 to get -4. And then we just figure out what all the y's are using this relationship. any questions on this particular topic? So let's go on and look at this topic. Finding the maximum or minimum of a quadratic function. Answer the questions below about the quadratic function f of x equals negative 2x squared plus 16x minus 34. The first question, does the function have a minimum or maximum value? That's controlled by this leading coefficient. If the leading coefficient is negative, which we have a negative leading coefficient, the leading coefficient's negative 2. When I'm negative, I fill down. So the parabola opens down. And the question is, do we have a minimum, which is a low point, or a maximum, which is a high point? Our vertex is a maximum. It's the highest y coordinate of any point on the graph. So we have a maximum. So I colored in maximum. When you have a parabola that opens down, you have a maximum. Next question. What is the function's minimum or maximum value? And where does the minimum or maximum value occur? Well, we know we have a maximum value. So when we say value in math, in algebra, we mean y value. The y is understood. So, and we're finding the x down here, so it makes sense that this is that we want to find the y up here. That perspective as well. And these questions may be in a different order, so be careful with that. So the first thing we want to do is find our x. So x is equal to negative b over 2a. So x is equal to negative. What's our b? It's the coefficient of x. This is written in descending power order. So our b is 16. So I plugged in 16 right here. Divided by this 2, just copy it down, and we need to find our a. Our a is the leading coefficient, which is negative 2. So I put negative 2 in parentheses here. So we have negative over a negative, which is positive. 16 in the numerator. 2 times 2, which is 4 in the denominator. We've already dealt with the sign. 16 divided by 4 is 4. So our x, which is equal to all of this, is 4. So x equals 4. That's the x coordinate at which the maximum occurs. Now to get the y coordinate, we just need to take our x coordinate of 4 and plug it in for 4 for x everywhere, and then figure out what the y is. So what relates? This is y over here on this side. This whole side can be viewed as y. So what relates y to x is our given function. So we want to take that 4 and plug it in for x in 2 places up here. So in other words, we want to find the y value when x is 4. So we put 4 in for x here, and we can write it as f of 4. This tells us the y value, find the y value when x is 4. And you will see that notation more and more if you go on in math. So it's important to understand what that means. This f means it's just really standing for y. The y equal when we are looking for y when x is equal to 4. That's what we're looking for. So we're plugging 4 in for x here and here. And that's what I did down here. Plugged it in here, squared it, plugged it in here, and we want to figure this out. 4 squared is 16 times negative 2 is negative 32 plus 16 times 4, that's 64. minus 34. And if I do that on the calculator, and let me see, so we've got negative 32 minus 30. You can do it in whatever order you like to. I sometimes like to do the negatives together. And that's what I'm going to do. I'm just going to calculate that. Negative 32 minus 34 plus 64. And I get negative 2. So however how you want to calculate that. So that is the y coordinate when x is equal to 4. So that negative 2 goes in this spot here for the maximum value. Any questions on this particular topic? Let's take a look now at an application problem, and this one isn't too tough, but it's important to understand it inside, outside, upside down, so that if you go on in math or when you get to more challenging problems in other classes as well in your academic career, that you're going to know how to interpret them. And interpretation of words comes up many places all over the business world. I worked in the business world for 5 years as a computer consultant earlier in my life, and it comes up all over the business world, and being able to interpret the words. And I know there's a lot going on with the vote in this country, and a lot of people trying to interpret what the laws mean, the constitutional laws and all of that. So yes, it is really important to understand. So I'll try to give you some tips. So an aircraft factory manufactures airplane engines. The unit cost C, capital C, in parentheses, the cost in dollars to make each airplane engine. So C is the cost in dollars to make each airplane engine. Depends on the number of engines made. If X engines are made, then the unit cost is given by the function C of X equals this. What is the minimum unit cost? So this business is concerned about finding the minimum unit cost. In other words, unit means per engine. They want the minimum cost per engine, per unit. That's what they're looking for here. That's what we're looking for here. So the first thing I would do is copy down the function and then have a note here about what C of X stands for. So the unit cost, and it's in dollars. So this is the unit cost in dollars. I like to know what my units are too, because sometimes that has saved me knowing what the units are and having them right there where I can easily find them. Sometimes when they're in the words, they get lost. And then the X is the number of engines made. We want the minimum unit cost. So we're going to have to find that minimum unit cost. You do notice that we've got an x squared term, an x term, and a constant term. We actually have a quadratic function here. So we can use our tools that we have learned today to do this problem. So the first thing I would do is find the x and the y. This entire side is y. So our x is negative b over 2a. That's negative. Our b is negative 306. It's the coefficient of x. Over 2, our a is the coefficient of x squared, which is 0.9. So this is 2 times 0.9. So we have a negative times a negative, which is a positive. 306, I'm going to use my graphing calculator. 306 divided by, if you have 2 or more numbers represented in the denominator like we do. We've got the number 2 and then a separate number 0.9. Or you have them in the numerator, or both. You need to put parentheses around them. So I've got the parentheses here for that reason. Parenthesis 2 times 0.9 parenthesis. And I get 170. If just for fun, I took off those parentheses. So let me take them off and tell you what I get. So I want to take off those parentheses using the delete feature of the calculator. Let me just do it this way. And then I'm going to put in 2 times 0.9 in the denominator. I get 137.7. Not going to get the correct answer. So that it enforces that we need to put parentheses around 2 or more numbers in either numerator or denominator if we have them. And in fact, you could have to put parentheses around both numerator and denominator in the same problem. Now, maybe not one of these, but another one. So once we have our x, we then, which is 170, we then take that 170 right here, plug it in for x here and here to figure out the minimum unit cost in dollars. So that means we would have 0.9 times 170 in parentheses squared minus 306. We're putting 170 in for x, so minus 306 times 170, and then just plus this. So when I did all of that in the graphing calculator, I got 8,580, and we're working dollars. That's the dollar, that's our unit cost in dollars, 8,580. Any questions on this particular topic? So I've got a couple more problems I want to take a look at. And I think we have time to do these. Yeah, we can. I think it's not going to take too long. This problem, this is just looking at a graph and answering some questions. Looking at a given graph of a parabola and answering some questions. So here's our given graph. I actually have it down here so it's nice and big, so we can take a look. The first question, part A, does the parabola open upward or downward? Downward, right? It's opening to the bottom. Downward is the answer. Next, part B. And stop me at any time if you don't understand why something's an answer. Please just give me a shout out, unmute your mic and speak. So that would be good. I really appreciate it and like when students do that because it helps me know where students are at in the course, and the more I know where students are at in this course, the better I feel I can help them. And that's what I'm here to do. So the vertex. Let's go down here to the big graph to look at the vertex. So we're looking at the vertex here. The vertex is this turning point. And if we want the x coordinate, we can go straight down to the x-axis to get it. That's between -4 and -2. That would be at -3. And then we want the y coordinate of the vertex. So we go straight over to the y-axis to get that. That's at 4. So the vertex, if we're given the graph, in this case, you can find it like that, and what we got here is -3, +4 for the vertex. So if you have any questions on part B, please let me know. Part C, find the equation of the axis of symmetry. So the axis of symmetry is this vertical dashed line right through the vertex. We don't make it solid because we don't want to confuse it with the graph. We want it to look like it's not part of the graph. And that keeps going up, up, up forever. So it keeps going up. So all we want is the equation of this if this were a vertical line, all we want is the equation of that vertical line. And the equation of vertical lines in general are x equals something. All the x's are the same on this dashed line. How can we find the x that we want to put over here? We can take any one of these dashes, or even down here, and trace it up to the x-axis to find it. It's at -3. We don't have the beauty, so that's our axis of symmetry. X equals -3. And they even remind us that we need an equal sign because equation really almost has the word equal sign in there. It has EQUA, it's missing the L, but that reminds me to make sure I put an equal sign in there. Any questions on that? We're not given the algebraic function here, so we can't find the axis of symmetry by using x equals -b over 2a. Going down here into part D, I'm just writing myself a note here. There. Okay, so looking at part D, we want to find the intercepts, both the x-intercept and the y-intercepts. And I did put another note here about the axis of symmetry. X equals the x-coordinate of the vertex. So the x-coordinate of the vertex here is one place to look. That is, here's the vertex, the x-coordinate is -3. So x equals the x-coordinate of the vertex, if that will work for you. So I wanted to mention that too. Now we're looking at intercepts, both x and y. Let's start with the x-intercepts first. When we're looking for an x-intercept, we're looking for where our graph intersects the x-axis. It doesn't necessarily have to cross the x-axis, it just has to intersect the x-axis. It can cross, but it doesn't have to. In our case, it is going to cross the x-axis because of what we're dealing with, but as for functions in general, when we're looking for x-intercepts, that doesn't have to be the case. A function could just hit the x-axis and come back up and go in the same direction. In that case, it would not cross the x-axis. So our intercepts are right here. So right here, between -6 and -4, that would be -5. And right over here, between -2, right here, between -2 right there, and 0, that would be at -1. The y-intercept. I remember working in lab time with students when I would go around and help them, meet them where they were at, and hopefully those days will come back quicker than we hope. Sometimes I hope they do. I know that most of our classes are remote in the spring, and you know, fall's kind of up in the air with respect to that. It just all depends. So let's take a look at the y-intercept. But I do remember some students would mistakenly think that -4 here was the place where the graph intersects the y-axis, and it sort of looks like it does, but I would encourage them to look below that too. So this one looks like it intersects the x-axis better, than the one above it or the one below it. So you want to look up and down to make sure you're picking the one. I'd hate for you to miss this, a question in ALEKS, just because you got the y-intercept wrong. So it's actually, in this case, it's at -5 where this graph intersects the y-axis. So the y-intercept is -5. Any questions on this particular topic? So what if we have to find x and y intercepts and we don't have a graph? So let's take a look at that. In this case, they're not asking us for y-intercepts, they're just asking us for x-intercepts. Let's go back to the graph that we just looked at for a minute. What if we wanted to find where we have a function line around and we wanted to find where the x-intercepts are? Well, this x-intercept is at -5. What's its y-coordinate? Its y-coordinate is at, if we trace this point over to the y-axis, it's right at 0 on the y-axis. So all x-intercepts have a y-coordinate of 0. So when we want to find an x-intercept, we can start. Yeah, that was the last one. Let me make sure I'm on the right document. We can start by setting y equal to 0. On x-axis, all y-coordinates are 0. So we put in, that means for our particular function that we're given, we can take out y and put in 0. So our function is right here. Take out that y, put in 0, and solve for x. That will give you and me the x-intercepts. So we put in 0 for y right here on the left, and we copy over these terms on the right, -x² plus 2x plus 24. So that's what we're dealing with, this equation right here. We want to solve that equation. So I don't want to work with a negative leading coefficient. I don't find it fun. I feel like I am less likely to get the correct answer, and it has a math person, I want to be as precise as I can be, so I would prefer to move it to the other side. If we move this expression to the other side, it will change the signs on all the terms. So when this x² goes over, it's going to become positive instead of negative. When this 2x goes over, it's going to become negative instead of positive. And when this 24 goes over, it's going to become negative instead of positive. And then that's going to leave 0 on this right side. So this entire right side is going to be, we're going to have equals 0. We then want to factor this. So we're looking for two numbers that multiply to give us 1 times -24, which is -24, and add to give us -2. Those numbers are 4 and -6. So 4 times -6 to check is -24. 4 plus -6 is -2, exactly what we want. So we write down two factors and we put x as the first term in each. We put +4 in one of them and -6 in the other. And we want these, whatever these two real numbers are, we don't know what they are, but we know that when we multiply two real numbers together, the only way we're going to get 0 is if one of them is 0. So let's find when x plus 4 is equal to 0. So we set x plus 4 equal to 0. We move 4 to the other side. We're going to get that on the other side, x equals -4. And when we write this one as x minus 6 equals 0, and we move -6 to the other side, it's going to change the sign. So we're going to get x equals +6. So our x-intercepts are -4 and 6. So that is what Alex wanted for those two x-intercepts separated by a comma, -4, 6. Any questions on this particular problem? I think that we've done enough work with looking at where the vertex occurs at. I don't think we need to do that. I think you should be good on that. That's my hope. So does anybody have any questions? We've got only a few minutes left. Let me make sure I'm taking another screenshot just in case. Anybody have any questions? Jesus, do you have a question? Well, let me see. I can't see who that is. I see a flashing. Oh, Jacob, do you have a question? Are you good? Anybody have any questions? Jacob, if you have a question, you feel free to unmute. If anybody has any questions or comments, please unmute. Anything I can do to help you, I've already got on my list that I'm going to upload my notes from today and from the class on Tuesday. I need to put the video from Tuesday's class and today's class in the link in Canvas for you. So anything else you can think of I need to do, please mention. I see a conversation. Oh, thank you, Jacob. Thank you for your kind comment. So I want you to have a nice weekend. I'll see you next Tuesday. Stay safe and have some fun. Take some time for yourself. We all need to take a breather from things that are going on in our lives. I think we've got more than we usually do. So take care, and I will see you next Tuesday. If you would like to stay around and chat with me about anything, you're welcome to do so. Take care and bye for now.